everyone, now we will see how do we find inverse of a 2 by 2 matrix. Okay, I'm giving you a shortcut to find the inverse of a 2 by 2 matrix. So again, when we want to find the inverse of a matrix, two conditions should be fulfilled. First of all, the matrix should be a square matrix. Okay, should be a square matrix. Matrix is a square matrix, and the other thing is its determinant should be not equal to 0, because if the determinant become equal to 0, the matrix become invert means we cannot find the inverse, because the formula of finding the inverse of a matrix is be denoted by A inverse. This is the notation. Okay, and it is 1 over the determinant of A times the adjoint of the matrix A. So adjoint of the matrix A is nothing but the transpose of the matrix of the cofactors. Adjoint of the matrix A. Okay, so I'll tell you this in detail when I will talk about the inverse of a 3 by 3 matrix. Okay, so as for A inverse, we are dividing it by determinant of A. If determinant of A is 0, this becomes infinity. So inverse is not defined. So that's why these two conditions are important. Now, coming to the 2 by 2 matrix. Coming to general 2 by 2 matrix, suppose if A is a general 2 by 2 matrix with the elements A, B, C and D, then its inverse is given by, means you can write it, remember it very easily, 1 over determinant of A. And then for this, what you have to do, interchange the position of the principal diagonal elements, like it's A and D, change the position, it become D and A. And for the off diagonal elements, position will be same, you will just change the sign. So it's very easy for 2 by 2 matrix. And you know that how do we find determinant of A for the 2 by 2 matrix? AD minus BC. Okay, so let's understand this with the help of an example. Say find A inverse if the matrix A is 2, 3, 7 and 5. So first of all, it is a 2 by 2 matrix, it is a square matrix, so it's okay, we can find the inverse. First find the determinant. This is step 1. So what will be the determinant? 2 times 5 minus 7 times 3, which is 10 minus 21. So determinant of A is minus 11, which is not 0. Hence you can say A inverse exists. Yes, it is possible that it can be negative, but it exists. Okay, then A inverse given by this formula, 1 over determinant of A, which is minus 11. What you have to do? For the diagonal elements, change the position. 2, 5 become 5 and 2. Elements on the principal diagonal. Remaining elements, change their sign. Minus 7, minus 5. So, what do we get? Now, 1 over 11, minus 1 over 11 is a scalar. So, it should get multiplied with all. So, on simplification, it become minus 5 over 11. Minus minus become plus 7 over 11, 5 over 11 and here minus 2 over 11. So, this is the inverse of a matrix. Easy?